Okay, we're going to do part 2 of the Introduction to Systems of Equations video. Before I get started, I want to tell you, or before I continue with this, or finish these examples, I do want to tell you this. Your homework last night, there's actually a different way to do the homework that I gave you tonight, not last night, tonight. So if you haven't done your homework that you got in class today, go ahead and there's a third video I'm going to put on here. It's just a quick video just to kind of explain how the actual homework is supposed to be done, because I was told there was different directions. So anyhow, let's finish the notes on Introduction to Systems. Alright, so this example 2 has this graph 5x minus 2y equals negative 6. What is the point of intersection with the line already there? So if you see on your notes, if you printed out the notes like you're supposed to, there's already a line on your notes. What I want to do is I need to graph this 5x minus 2y equals negative 6. Well, the problem is I can't graph it in standard form necessarily. You can, but we haven't talked about that. So what I'm going to do is I want to solve this for y so that I can graph in my y equals mx plus b form. So I'm going to subtract 5x from both sides. That cancels out, leaving me with negative 2y equals, notice I cannot combine these because they're unlike terms, so it's going to be negative 5x minus 6. Get y by itself, I've got to divide both sides by 2, negative 2, everything by negative 2. That cancels, leaving me with y equals, okay, negative 5 over negative 2, it's just a positive 5 halves x, and then negative 6 divided by negative 2 is a positive 3. So that's not the answer. I need to go ahead now and take this information and graph it on that Cartesian plane already over here. So let's take a look. Again, this is a good review on how to graph. First thing I need to do is I need to start at my y-intercept, and I need to plot my y-intercept. Again, my y-intercept is at positive 3, so I'm going to go up 1, 2, 3, and I'm going to put a point on my y-axis. Again, some of you guys are plotting your y-intercepts on the x-axis. A y-intercept needs to be on the y-axis. Then I'm going to look at my slope now, which is 5 halves, and I'm going to look at it again as rise over run, so m equals 5 over 2. This is my rise, this is my run. So from my y-intercept, I'm going to go up 5, 1, 2, 3, 4, 5, and then I'm going to go over to the right because it's positive 2, 1, 2. I'm plotting a point here. Again, I'm going to get my ruler out, and I'm going to draw my graph. My line. Okay, so there's my line of 5x minus 2y equals negative 6. As long as I did all this work right, that's the line. Okay, so now I need to find the point of intersection, and really, this point of intersection, you can turn that into the solution. I need to find the solution with the graph that's already there. So my solution then to this system of equations is going to be this point right here, because that's the point that they have in common. Remember, the intersection is the solution, the point that they have in common. So my solution is this point right here, so I need to figure out what this is. It's over 2, 1, 2. Okay, up 1, 2, 3, 4, 5, 6, 7, 8. So it's over 2, up 8. So my solution is 2, 8. If I ask you how many solutions you have, your answer of this would be 1 because you have an intersection. Now, one intersection is a solution. Then if I ask you to name that solution, naming that solution would be this 2, 8. That's your point, 2, 8. Okay, make sure you get that down as we move on into the next part of our lesson. We have 2 more examples and then we'll be done. All right, let's look at example 3. Okay, example 3 says, determine which is the point of intersection for this system. Okay, again, what we're doing here is we're still solving a system, but now we have multiple choice to find our answer. Okay, so we can do it a couple different ways. I believe right now, there's a couple different ways we can do this. One, we could graph this and see if there's an intersection. Okay, and see what the intersection is. The other thing that you could do is you can plug both of these, all these points in here, and see, does it work for both equations? And let me go ahead and do that for real quick. Okay? So, I'll take y equals negative x plus 1. Okay? That's the first equation right here. I'm going to plug in a. So, instead of y equals negative x plus 1, I'm going to plug in 0 for y. This is x and y. So, y equals, now I have negative 1. Okay, be careful here, because there's already a negative out here. This negative 1 goes in there exactly for the x. And then plus 1. So then I have 0 equals, negative 1 becomes a positive 1. So I have 1 plus 1. So 0 equals 2. Does that make sense? Of course not. So 0 does not equal 2. That means this point does not work in that system, in that equation. Sorry, in that equation. It might work in this equation, but we don't care about that. We want the one that works in both equations. So this is definitely not the answer. Okay? So let's do the same thing with b now. This time, instead of y, again we're still doing y equals negative x plus 1. Instead of y, I'm going to write 1 equals negative 0, which doesn't make sense, but it's fine, plus 1. So negative 0 is just 0, so 1 equals 0 plus 1, 1 equals 1. That makes sense. But that only so far makes sense for this equation. So if that's the case, I've got to keep going. Okay? So I'm going to put this now, the b values, into the second equation. So I'm going to do 5 times 0. I'm sorry, let me go ahead and write the equation again so you know what I'm doing here. This is 5x minus 2y equals 5. So then I have 5 times 0. I'm just plugging in the x value. Minus 2 times 1. Just plug it in the y value. Equals 5. Let's keep working it out. 5 times 0 is 0. Negative 2 times 1 is negative 2. Equals 5. So 0 minus 2 is negative 2 equals 5. Negative 2 does not equal 5, so that doesn't make sense. So b works for this one, but does not work for this one. So it has to work for both. So b is out. So b is not our answer. Okay, let's look at c now. Again, I'm going to start with y equals negative x plus 1. So y equals, I'm not going to put y equals. I'm going to place y with 0. So 0 equals negative 1 plus 1. So 0 equals negative 1 plus 1 is 0. So that makes sense. So for c, okay, we're on c right now. For c, the first equation does work. So let's go to the second equation. We have 5x minus 2y equals 5. Okay? I'm going to plug in 5 times 1, because that's my x value, minus 2 times 0, because that's my y value, equals 5. 5 times 1 is 5. Minus 2 times 0 is 0, equals 5. 5 minus 0 is 5. 5 equals 5. Does that make sense? Absolutely. Since those both make sense, C is my answer. Because this point works in both equations, and it makes sense in both equations. Now, we just did a whole lot of work for that simple problem. Normally, I would not tell you to do that. I wanted to do it this way so that you could see how this works, how the process really works, and how both of them works. What I would probably do is I would use a method called substitution, which is not, we haven't talked about yet, we're going to talk about that later on. Or I would have maybe graphed this, since we've already talked about graphing a little bit. This is never really the easiest way to do this. This is a worst case scenario. If you forget how to do anything else, you can do this all you want. Okay? But it takes a long time, as you can see. That's a lot of work. Okay? Like I said, rest assured and be comfortable and be glad knowing that I would not ask you to do this every time. You're going to use one of the three methods, which is graphing, elimination, or substitution. Okay? In this case, I probably would use substitution, but we don't know that yet. Okay? Alright. Go ahead and make sure you have that down before I move it up, and then we're going to do our last example. Okay, example 4 says Greengrass Inc. charges an initial fee of $15 plus $10 an hour for lawn services. Their main competitor, S&G Lawn Care, charges an initial fee of $35 plus $8 per hour. Complete the table below. Okay, so what we do is this. We say we know we have for hour 1, the Green Grass Company, it's $15 plus $10 per hour, so 10 times 1 because there's 1 hour. Our cost then would be 10 times 1 is 10 plus 15 is 25, right? 10 times 1 is 10 plus 15 is 25. On the other side of that, the competitor S&G, they do $35 plus $8 per hour. In this case, we're doing 1 hour. So 35 plus 8, because 8 times 1 is 8, so 35 plus 8 is 43. So the cost for this one would be 43. So we're going to go through the table and fill this out. We have 15 plus 10 times 5. Then I have 15 plus 10 times 8. All I'm doing is replacing that number in the parentheses with the number of hours, because that's what we're multiplying. Then we have 15 plus 10 times 9. 15 plus 10 times 10. And then 15 plus 10 times 11. 15 plus 10 times 15. Down here, we have x. I'm just going to replace the number in the parentheses. So 15 plus 10 times x. I'm not going to put it in parentheses because it's a variable. That's how we get our equation. Remember, we've done this before. This isn't anything new. That's how we get our equation. So our equation for green grass is y equals 10x plus 15. It's just a little side note. So let's go ahead and figure out the cost then. 10 times 5 is 25, 30, 40. It's $40 for 5 hours. For 8 hours, we have 10 times 8 is 80. Okay, plus 15 is 95. Plus 9 hours, 9 hours is 90. Plus 15 is 105. 10 hours, okay, it's 100 plus 15. You have 115. 11 hours, you have $110 plus 15. You have $125. 15 hours, you have 150 plus 15 is 165. And then, of course, this would just be y equals 10x plus 15. That's our equation. Notice how there's a jump in here. That's why the numbers jumped. They weren't just going by plus 10. All right. The last, over here on the lawn care, S&G Lawn Care, I'm just going to do the same thing I did here. I'm going to just replace the number in the parentheses with the number of hours. We have 5 hours here. Oops. I guess I have to have the 8 first. So 8 times 5. 35 plus 8 times 8. 35 plus 8 times 9. 35 plus 8 times 10. 35 plus 8 times 11. 35 plus 8 times 15. And then I have 35 plus 8 times x. I'm not going to put that x in parentheses. Again, here's our equation. Y equals 8x plus 35. Okay? So let's go ahead and get the solutions. 8 times 5 is 40 plus 35 is 75. Okay, 8 times 8 is 64 plus 35, excuse me, is 99. 8 times 9 is 72 plus 35, which is 107. 8 times 10 is 80 plus 35, which is 215. 8 times 11 is 88 plus 35, which is 88 plus... Oh, I messed up on here, sorry. 88 plus 35, which is 123. 8 times 10 is 80 plus 35. I put 135, it's 115. 8 times 15 is 23 plus 8 times 15 is not 23. Is 120 plus 35 is 155. And of course we have y equals 8x plus 35. Okay, so now I've filled out my table below, and this is going to help us with a lot of information. It says find the point of intersection in the table. Where are the points the same? Where are the hours and the cost the same? So I'm looking for the same number in the cost value. These are different, these are different, these are different. Now here we have the same value. At the 10-hour mark, we have the same value. Okay? So it's 10 hours in which they're the same. So why is this important to a customer? What does this signify? Well, if you look at everything before 10 hours, who's cheaper? Who's cheaper before 10 hours? Well, for 1 hour, the cost is $25 for green grass, but $43 for S&G. So what is happening is green grass is cheaper until you get to 10 hours. After 10 hours, green grass becomes more expensive than S&G. So this is important because if I only have this many hours, if I have less than 10 hours, I want to go with green grass. But if I have more than 10 hours, I want to go with S&G. For 10 hours, it doesn't matter who I go with because it's the same. So that's why that's important. So if I only needed 6 hours of lawn care, which company would I choose? Well, 6 is less than 10 hours, I would go with green grass. If I wanted 20 is greater than 10 hours, I would go with S&G. This is a real world scenario of where we would use systems of equations. So this is actually relevant. It's a lot of work, but this is something that you're going to have to invest in and do this because this is very important. Alright, that's it for our notes. Like I said, come in ready tomorrow to work, and then there's a third video that I'm going to show you that will have our homework. So I'll see you tonight or tomorrow. Good luck.